Hello, Professor Sargent here with you again. Let's continue talking about confidence intervals and hypothesis testing with just one new wrinkle added in. That being that we are getting our information from a matched pairs experiment. So again, we are getting our information from a matched pairs experiment and either come up with a confidence interval for the population mean or testing a hypothesis. In this case, we're going to be talking about within the matched pairs, taking the score from one minus the score of the other, always going in the same order in each pair, consistent order of subtraction, looking at the mean difference. We will have information from a sample about the sample mean difference, which we will call D bar, and we are trying to do inference on mu sub D, the population mean of the differences. Previously, for a confidence interval, we would have had the following formula. Your point estimate for the population mean was X bar, and we're replacing that. Well, let's get to that in a moment. X bar plus or minus critical T value times standard deviation divided by the square root of the sample size. We're going to replace X bar with D bar and S with S sub D for our hypothesis testing. We had that T was equal to X bar minus the claimed mean divided by S over square root of N, showing up again. Same replacements. Now we'll have the sample mean of differences, D bar, and standard deviation for those differences. Also, the null hypothesis in a matched pairs experiment hypothesis test will always be that there's no difference between the scores within a pair. No difference, i.e. zero difference, but D bar minus zero is just D. That does not mean that you always have mu equaling zero being claimed in a hypothesis test. This is just applied to the case of matched pairs experiment. Let me share a little more from the textbook here. Just a moment. Okay. What are the conditions under which we can apply this? I want to find that for you. But notice here, we are seeing what I just wrote out. Conditions. Come on. First of all, you have that the scores within a pair, those are dependent. For example, you could have two measurements by two different machines, for example, measuring the same thing. So those scores are going to be dependent on each other because they're both measuring the same item. Or we could be talking about pairing up brothers and sisters and measuring their heights and finding the differences in height, for example. Those would be dependent because of genetics. However, the pairs that you get, those are independently obtained from the population. So you would want a sample size that is no more than 5% of the population size. Furthermore, we're getting information from simple random sampling or matched pairs design experiments, and either the differences are normally distributed with no outliers, or the sample size is greater than or equal to 30, so that the central limit theorem would start to kick in. All right. So let's take a look at an example.